Okay, so this is another model that we can use, but this one they will display the model, or they will create the model in a tree format. Okay, so basically this is used when you want to do regression, and the output will be in the form of a tree. So this is best used when you have a liked survey. So for example, you put like poor, average, and good or excellent, and they have values. So this is more into nominal variable. Okay, so in which your label or your dependent variable has this rank or order. Okay, so this regression tree were introduced long time ago, and they are part of the seminal classification and regression tree. Okay, so basically they are looking into how do you model data that use nominal values. So this is for the ordinal. Okay, so for the logistic we use for nominal, and for regression tree we use for ordinal. Okay, so this one has order or ranking. They have ranking. Okay, so in regression tree they do not use linear regression. Okay, but they make prediction based on the average value of example. So this is when you have remember you have IV, right? And you have the dependent variable. Okay? So what they want to do is they want to model your data in such a way that they will reduce the standard deviation, which is the differences between the values and also the mean. Okay, let me show you the. Okay, so for example, like this, at the bottom here are all your output. This is your dependent variable. Okay, so what they want to do is, as you go from here and you go down to the leaf, we want to split the data so that you will have the maximum standard deviation reduction. So when you coming from here and then you go to here and so on, when you are here, this range of value, okay, or the standard deviation will be smaller. Okay. For example, like this, if we split the data into two parts, or the average value that you have here and the average value over here, when you find the standard deviation, it will be smaller. Okay, so we want to model our data using this model, but the scale that we are looking here is 1 to 10, so meaning that we have ordinal values. Okay, in later on we will go step by step on how do we perform the regression tree in order to model wine testing. Okay, later on. Okay, so this one is looking at how do we group the data by using the measurement of standard deviation. So we will group the data so that the average of the data give you the lowest standard deviation. Okay, so we are looking at the standard deviation here. Okay, so how do we ensure that we have the maximum standard deviation reduction? We will try to split the data into two. So remember that when we look at the tree, just now basically we are dividing the data into two parts. So by dividing them into two parts, we are trying to have the maximum standard deviation reduction. So this is the standard deviation before you split, and this one is standard deviation after you split. So it could be more than 2 branches. So this one is the number of branches that you have. So this is the weightage. And this is the standard deviation for that particular branch. Okay. So for example, this is our original data. Okay. So what we want to do is we want to model this. So we can split them into 2 or 3, but in this example, to make it easier, so we split them into 2. Okay. So one is split using feature A, one is split using feature B. So which one is better? Which one will give you the higher standard deviation reduction? Okay. So we will show you in this example. Okay. So if you look at the formula that we have here, basically we need to know how what is the number of data that we have in each of the partition that we have. So this one tell you the number of member in that in the whole data that we have. This is the number of data that we have in each of the partition. This is the standard deviation for that particular partition. So we add up the total standard deviation reduction here and minus this one. So this is before splitting, this is after splitting. Okay. So first we need to find the standard deviation for this before the splitting, and after splitting using feature A, we will find the standard deviation for A and also standard deviation for B. So we will compare. Okay, so which one is better? Okay. So in order to illustrate this one, we use this R statement also. So basically, the first one is just combining all this value to set up this. Okay, and then for attribute 1, attribute A, we use this, and A2 is this one. Okay. And also the attribute B, this one. So this 5 statement is basically just to set up the scenario here. Okay. So now we can use the function SD to find the standard deviation for this original data here, minus, because we have minus here. So since we have 2 partition for feature A, so we will have two partial. This is the, let me use different color. So this is the first part. So basically this is the first partition, and the second partition is this one. Okay, so this is just the weightage, and then this is the standard deviation for 81, then plus the weightage for the second partition times the standard deviation for the 82. Okay, so we get the SDRA for the first feature A. We will repeat for the feature B. Then when we compare, because we want to maximize the standard deviation reduction, so we want to get the higher one. So we choose feature B is best used to split the data. Okay, so this is the illustration on how the model is trained or is optimized to maximize the standard deviation reduction. Okay, so of course, when we look at the scenario here, this is only 2 two parts, two feature A and B. So in the real situation, basically we want to do the whole thing. Okay, what is the standard deviation reduction here? And then we do for every partition that we have. So it means that if we have n number of column here, no, yeah, no, n number of rows here. This is rows. So that means we have n minus 1 number of testing to find the best standard deviation reduction. Okay. Okay. So to illustrate this one, we will look into the wine testing. So in this case, we will use the regression tree, and we will model the tree in order to capture why people put 6, why people put 9, why people put 2, and so on. Okay. So the data that we have consists of 11 chemical properties. So basically we have 11 column independent variable. Okay. And we have one column that indicate the evaluation or the score for the wine. Okay. So we have 4,898 wine sample. Okay. So what we have here is the 11 properties of the wine that we have. And this is the ordinal data that we will model. Okay, we get the data from the white wine. It will consist 4,898 rows containing 12 columns. Okay, so you see the data that we have here, all numerical values. So what we want to do is we will form a tree. We will train a model that will use all these 11 independent variables to model the dependent variable, which is the quality of the wine. Okay. So we can explore our data. So this one, we can look at the histogram of the quality column. So majority of them put 6. Okay, less people put 3, 4, and 9 here. So what we want to know is what make people key in 6 or 7 or 5 or 8 and so on. So based on the 11 properties, chemical properties, then we can model this data. Okay. So before we can model, so we can divide them into training and testing. Okay, so this number is depend on you. Okay, but normally we say 70% will be used for training, 30% will be used for testing. Okay, so this is just to split them into training and testing. Okay, now we are using the regression tree, so we need to install this package called rpath. Okay, so the rpath consists of the regression tree. Once we have installed them, then we upload into the memory. Then we can use them. So to use this one, we say, okay, I will want to produce a model M. I will use regression tree, and this is my dependent variable, and I will use the list of independent variable that I get to model my dependent variable, and then I will use this data. Okay. So once I get the model, once I have trained the model, then I can use that one to perform prediction here. So I will say I want to predict using this model, using this data, and this is the type of output that I will produce. Okay. So in this example, the quality will be our dependent variable. I will model them using all the remaining variable that I have, which are the independent variable, and this is my data that I get from the training data set. So with this statement, I have produced my model here. And if I tap this one, basically I have this tree. But this is a bit difficult to see, but we can use this package to visualize them. This is the rpath plot. So we install and we upload into the memory. Then we say, okay, this is the model that we have from the previous one. This is the model that we produce. So I simply call this rpath plot, and then this one will tell us the number of digits that I will need to display. So using this, we can tell that if the alcohol is less than 10.9, I will go here. So basically, they are split into two partitions using the alcohol features. So meaning that when we split the data into two partitions using the attribute alcohol, at that particular value, I have reduced the standard deviation for the alcohol that we have. So, and it goes here for this one, they look at the volatile acidity and then go here and so on. So when we reach at the leaf here, this is the scale is supposed to be 1 to 10, right? Okay. But this one give you the 5.26, 5.26 because this is the average. Okay. So over here, this is 5, this is 6, this is 6, this is 5, this is 6, this is no 5, this is 6, and 7. So since most of our data is in between 5, 6, and 7, so our model can produce that one. Okay, so if we were to answer like why people put 1 or 2 or 3, they are not included in the model because maybe less number of people put there based on the histogram that we saw just now. Okay, there is another way on how we can visualize this is by using this. So over here we are looking at different package. So we use the type 3 plotting, and we see that we have better understanding here. So this is when the alcohol is less than 10.85. This is greater or equal to 10.85. And we go here again, we look at the volatile acidity and so on. Okay, so this is the number of sample that we get. So basically, they are 24% from the whole data set that we have. Okay, so this is very useful when you have a Likert survey. So you can use this regression tree to model your data. Okay. So that is only for the modeling. So to perform the prediction, so we use this model to predict the test data that we have. Okay. So so what we can do is this prediction, we will have all the value for the so this one will produce the predicted quality. So we want to compare this one with the actual quality that we have in the wine testing. Okay. So over here we look at the summary, what is the mean and what is the max and what is the average here. So we compare with the mean max and also the average for the actual data that we have. Okay, so they are more or less the same, but what we can do is we can test the correlation between the actual quality and versus the predicted quality. So this is the predicted quality, this is the actual one. Okay, this is the actual. So we want to see the correlation between these two. This is the predicted value. Okay, so we can find the correlation here by using this command, and correlation is 0.53. Okay, so the aim is to have higher value of correlation. Okay, so somehow what we can conclude here is that the regression tree is able to model the data that we have because we have correlation of 0.54. Okay, so we must get correlation above 0.5. Okay, so that's how we validate the finding, and I think that's all. So for this, I will prepare a practical for this one also. For your information, I have posted the assignment, right? So you will have